All right, so we are at time, so we can get started. Thank you, everyone, for coming. I hope you had a first good day. You started a good day. So we realized that this session and the reception beer is the only thing that sort of separates you from the beer in the room nearby. So we're trying to get your spirits up before you can join and start the festivities. And you can ask us questions. So my name is Boris Baryshnikov. I work on the Azure Compute product team. There are these two fine gentlemen with me, Alfred and Jerome. I'll let them introduce themselves when they are actually starting their parts of the presentation. And we are the team of people at Microsoft who help you run your Linux workloads on Azure. In the next 45 minutes, what we're trying to do to cover and to explain you what different services you can have and that you can actually successfully bring your Linux workloads to Azure. And the goal of our next 45 minutes is to show you all different things you can have, not necessarily to go into them in very specific detail. Feel free to stop by at our booth in the hub and ask us detailed questions for very specific workloads or very specific problems you may have. And this will help and understand and get your feedback as well, improve the platform. We'll focus on a lot of Red Hat things because we have a Red Hat partner here today with us, and we will just illustrate the examples and demos we have today using Red Hat as one of the examples. Now, I'll begin with looking at a typical cloud journey. So some of you may have started, some of you may have been actually in this journey for quite some time, but typically you have your usual stack of services running in your on-premises environments, be that mail servers or your web applications or databases or any kind of identity services. And usually when you look at those things and try to move them into the cloud, there are respective either managed services in the cloud, or you can simply run those services using Azure Virtual Machines. Now, as you go through various services, and let's say you look at the file servers, you look at the lump stack web applications or the custom applications. So some of them will be moved to the PaaS services, some of them will stay on the VMs, and some of them will actually stay on premises. So there's no print services available, at least not in Azure, that you may need to keep on premises. And obviously, as you go through this journey, not everything needs to move to the cloud. One of the benefits, one of the journeys that we are trying to show is that you can actually have that journey at your pace, and you can move individual components at the time where it's convenient to you. Now, how important is Linux to Microsoft? So you may have seen this information in the various keynotes, is that we're running more than half of the VMs on Azure that are running some version of Linux distribution. Now, if you think about it, so we are the traditional Windows company of many years ago. We're running more Linux on Azure than we're running Windows. Now, if it tells you anything, that the fact that it's super important to us, that we need to make sure you're successful in Azure, that's what we'll try to do. I'll start with a video of one of our customers of how they moved and what are they using in Azure to run their Linux workloads. Let me run the video.
Lufthansa Technik is a service provider for airlines. Being on the leading edge in terms of aviation technology, it was a natural fit for us, connecting our physical services to a digital platform.
We collect billions of data points from different aircraft systems. We always know about the state of the aircraft, so there are no unplanned maintenance events in the aviation industry anymore.
To face the challenge with growing amount of data, we decided to create a digital twin of an aircraft. The product is called Aviatar.
If we have an anomaly with the engine, the aircraft sends data to the ground. So when the aircraft arrives, the corresponding action will be ready to be performed by the mechanic. We want to be the open alternative to closed ecosystems in aviation, running them all on Microsoft Azure. When we started Aviatar, we were very short in time. We started with on-premise infrastructure components. We noticed quickly that our development and iteration speed would be better suited in a cloud environment.
It was quite easy to lift and shift our Red Hat technology stack that we had on-premise into the Azure cloud.
98% of our workloads are running on Azure VMs that are powered by Red Hat Enterprise Linux. Since managing databases is a huge effort, we try to introduce managed databases wherever possible. So we're using Azure SQL databases. Our machine learning and prediction algorithms are running on a Cloudera Hadoop cluster, so we can easily spin up new clusters to crunch the numbers. All the raw data is stored in the Azure Data Lake store. Streaming data between the different microservices takes place in a central Kafka cluster that runs on Azure virtual machines using Red Hat Enterprise Linux, and they're working like a charm on Azure.
We were able to speed up in our software development and increase flexibility and scalability of our solutions.
Moving Aviatar to the cloud reduces operational effort by more than 50%.
We are using technology to make an impact in the physical world. For a normal-sized airline, the cost savings might be in the double-digit millions per year. Our vision is to keep Aviatar growing, reach all airlines in the world, and make their operations more reliable.
All right, so this was a Lufthansa Technik. Now, you may be thinking like, well, this is not the industry I'm in. This is not something that I'm going to run. So if you're looking for more examples of the case studies of something that people actually running their Linux workloads on Azure, what I advise is, and we have a reference in the appendix slides, and you can download this deck from the website. If you go to customers.microsoft.com and search for any of the companies you see on the slide, you will see which part of Azure and how they're using which part of their Linux workloads they moved to Azure and what kind of technology are they using. So this would either, and I'm realizing some of you may be from the companies that I'm showing on the slide. So definitely stop by and ask questions at their booth in the hub if you have any particular questions about moving your particular workload or about the problems you may be facing today. When you start your journey to the cloud, we have a variety of things in Azure. And there are a lot of services that either built for Linux, built on Linux, or built on Linux first, or support Linux just natively out of the box. And what you see on the slide right now is the different services that either satisfy one or more of these categories. And again, you can obviously run Linux virtual machines, you can run Linux virtual machine scale sets, and all the higher level services that would either run with or support Linux and make it easier for you to move your workloads into Azure. Again, the choice is very, very large. You don't have to jump and use those services from the beginning, but they're available to you, and that's the power of the Azure platform. There's also a large variety of the third-party applications available in the Azure Marketplace. And one of the things you can do, you can find the partner you typically work with and look at their solution or look at their offerings available through Azure, which will help you look at how you move the workloads from on-premises into the cloud. Now, what are we doing and how are we doing this stuff? So why, as I was saying earlier, so why is it super important for us to run those workloads on Azure? It obviously starts at the fundamentals. If you look at the lower part of the slide, you will see that all of those things mentioned, with probably the exception of the cloud init, they actually applicable regardless of the operating system. So it's super important that VMs start fast. It's super important that they're reliable and highly performance. And you should be taking care of security and high availability. So Cloud Init is one of the features that is Linux specific that allows you to customize and modify your VMs the same way either on premises or in the multiple clouds, which makes it much, much easier to move your workload in the cloud. Again, our goal is to ensure that all the distros we have available in Azure in the gallery support Cloud Init initialization. Now, with that being said, once the fundamental is something that we've done, so what are we looking at in terms of building in any particular area? And you can see multiple areas where we focus on things. So it could be either kernel or image building type of functionality. So we either provide the Azure tuned kernels, something that we know will run well or tuned for Azure so that you can get the image out of the box and it will run faster than your typical home-built image that you might be using on premises. Using the tools like Image Builder or Shared Image Gallery that will help you build image and share the image and use it across multiple environments. Or using different licensing models where either you pay to Azure, you pay by the minute, or actually the charging works by the second for whatever the version you're taking, like be that RHEL or be that something else, or you can bring your own license, bring your own subscription. There are a number of tools that help you with automation, help you with the later stages of your journey, so that's when you're actually starting to refactor things. And then services like Red Hat Update Infrastructure, something that provides updates to your VMs, again, directly out of the box. You don't need to connect anywhere. It's all configured for you. And tools that help you with the diagnostics that are very Linux specific, like Serial Console, and Alfred will be showing some of the demos. Again, looking at this overall picture, those are individual components. One other thing that we're carefully looking at is what is the Linux end-to-end experience to you, the customer? And is that Linux end-to-end experience is actually helping you to achieve the result that you typically expect out of the Linux workload? I'm actually going to give an example. I'll probably spend a minute on that. So we've been flying from Seattle, and some of you may be on that same plane. And when we landed so we were flying through the connection in LAX in Los Angeles. And the first thing that the lead flight attendant told us, like, hey, that's another Delta flight on time. And then we sat on the runway for about 35 minutes only to realize that the gate was not working, the jetway was not working, and we had to be pushed back and put in another gate. And we had only 1 hour flight between our connection flight. So the point is, Delta reported their success. They landed the touchdown from the wheels up to wheels down. They reported their success, but we were almost late to our second plane, right? And to them, the end-to-end that's where we're actually looking end-to-end in Linux. It doesn't really matter that you actually landed one plane. Did you get your customer to the final destination? So that's the end-to-endness from our point of view when it concerns Linux. Is it easy to work with a particular technology? Do the technologies match? Is it actually natural to you how you use those things? Again, that's a super important focus to us. How do we do this? As I mentioned, just the questions that were at the very beginning, we start with the partnerships. And those partnerships are actually there for you. So when we work with the likes of Red Hat or any other company that you see on this list, you get some benefits that are maybe unique to Azure. Examples are integrated support, having services that run jointly by the companies, and things like, again, I mentioned integrated support, is that when you call either company, we actually take care of your ticket, shifting it between the companies without having you file it individually with every, without a particular partner. Now, with that, let me pass it to Jerome. So Jerome, why don't you introduce yourself, and you have the mic.
Hi, everyone. Nice to meet you. My name is Jerome Buto. I run product management for the Certified Cloud and Service Provider program. So I've been working with Boris for many years now on enabling Red Hat technologies in Microsoft Azure. Some of the things that we've done together, historically, our relationship started around Hyper-V, enabling Red Hat products to run on Hyper-V. And over the years, we expanded to include Azure. And with Azure, we focus on making sure Red Hat customers have a really great Linux experience inside of Azure, focusing on the integrated support, but also support for the new instance types that Azure releases on a regular basis. Afterwards, we expanded the relationship to also include SQL Server, making sure SQL Server works especially well on Red Hat Enterprise Linux, making sure that we get performance benchmarks, and making sure the Linux system works well for SQL workloads. Recently, we'll also launch Red Hat OpenShift Container Platform on Azure, Arrow, which is our container platform available as a service in the Azure platform. And Alfred will show a little bit about this a little later. And finally, last on this list, but not the least important, SAP workloads. We've done a lot of work to work together to make sure that SAP workloads work great on RHEL, on Azure, together to fit the needs of our customers. So taking a look at some of the services that we have available, we first started with making sure customers can put their images into Azure. So that started with a somewhat manual process where a customer builds the image and imports it into Azure. We then expanded to include two things. One is Azure Image Builder, which is available from Azure to build images of RHEL. But also Red Hat has our own image builder, which will build images for you. So if you do want to bring your own subscription, bring your own image, you're able to bring that image into Azure that fits the needs that you have, as opposed to having to rebuild every single time you go into the cloud. We've expanded also to include pay-as-you-go images, which are available in the gallery and deployable via 1 or 2 click. As a gentleman was asking earlier if RHEL 8 is available, so if you go in the gallery, you could just go find the RHEL 8 image, press a couple buttons, and then you have your instance running. So it's really easy, really fast, especially with the fast provisioning features that Azure provides. And finally, we have a lot of other services that sit around it with a whole portfolio being available in Azure. So you can use middleware portfolio, you can use Ansible for automation, you can use OpenShift for container management, and we also have an update infrastructure that's available within Azure so that if you don't want to pull content from outside of Azure, you can do it from within Azure. So let's move to the journey to the cloud. I'll pass this off to Boris to go into the journey.
All right, thank you, Jerome. So as I mentioned at the very beginning, you're probably going through either on this journey or you're looking into it. And the easiest one of them is rehost. Rehost means you want to just pick your workload and drop it into the VMs into Azure and just make it run. So that's the easiest one. In this case, the how fast you can move it, and minimum code changes. That's what you want to happen in this case. The other two areas we will cover is the refactor and the re-architect. Again, we'll get to them as we go through the demos. And few things that you see on the slide is what would help you to do that journey, what it would help you to move the VM into the cloud. So there's a variety of the gallery images. You can start with that. You can use the portal. You can use the CLI. And you literally don't need to do anything else. So once you provision your VMs, the first thing you would check is you just put a VM into the Azure resource group. You put some network security group around it, and then you will see if your workload actually can run the way you want it. So the typical thing that people find out in this stage is, does the size work for you as you need to? Is there any latency issues? Is there any location issues, or anything else that might be coming into the process? Again, this is very much the exploration process, and you have a lot of choices in the different OSs that you'll start your image with. But it's easier to show this instead of just talking to it. And with this, I'm going to pass it to Alfred, and who's going to do a few demos for us to illustrate that point.
All right. Thanks, Boris. So hi, I'm Alfred. I'm PM on the Azure Compute Linux Workloads team, and I'll be showing you a demo of a few different things. We've got some Red Hat image overview. We've got the Azure Image Builder, as well as the Azure Serial Console. So let's try to blast through these. So let's just start off with how you find Red Hat images in the Azure portal. So this is the Azure portal. You literally just search for Red Hat, and you'll have a whole list of images that we have right here. This is what we have in the Azure portal, and you can see we've got RHEL 8. So for the gentleman that was asking about it, we have a RHEL 8 available right here. But this list is not fully comprehensive. So if you want a fully comprehensive list, you'll want to go into the Azure CLI. And hit that, and what you'll get is a big, long list of every single Red Hat Enterprise Linux that we have published onto Azure. And it'll look intimidating at first, because this is a huge list. But the one takeaway I want you guys to have is that there are basically two types of images, as Jerome kind of alluded to. We've got pay-as-you-go, and we've got bring your own subscription, or also known as BYOS. I'll be calling it BYOS for the remainder of this. How do you tell which one's pay-as-you-go, which one's BYOS? Everything is pay-as-you-go except for the ones tagged with BYOS. Those are BYOS. What is the difference between pay-as-you-go and BYOS? Well, the pay-as-you-go images, there's two main differences. One's billing and one's updates. The pay-as-you-go will charge a little bit extra on top, but because they charge a little bit extra on top, you will get Red Hat updates from the Azure Red Hat Update infrastructure. On the other hand, the bring your own subscription doesn't charge that extra fee, but you are responsible for your own source of updates, whether that is through your own satellite or through Subscription Manager. So how does that look in practice? Let's head over to here where I've got a couple of VMs already provisioned. Here's our RHEL 7.7 Bring Your Own Subscription VM. Let's SSH into that thing. And let's try to list what repos I've got. So as you can see, there is nothing. I'm getting an error. It's telling me, hey, I need to register this because this is a bring your own subscription. I need to use my own Red Hat subscription and register this VM in order to get updates. On the other hand, let's head over to the pay-as-you-go VM. We'll SSH into that. And you can see we've got our nice long list of repos that is available to you through the Azure Red Hat Update infrastructure. You see RHUI throughout that text. That stands for the Red Hat Update infrastructure. So that's RHEL images. Now I'm curious, how many of you guys have built images before? How many of you guys enjoyed that process? A lot of hands going down. Yes, OK. So yes, we realize image building is painful. It's tough. There's a lot of things you need to learn. You need to learn about the OS. You need to learn about your image tooling. And we have a tool to solve that for you. Jerome mentioned the Red Hat has an image builder. Azure also has an image builder. In this next demo, I'll show you guys a little bit about the Azure image builder. So the Azure image builder is a quick overview. It'll take in a source image, which can be a platform image, so like one of these guys from the marketplace. And you can add your own customization scripts to it. And then you can tell it where to distribute it to, and it'll magically build you an image prepared for Azure. So super quick, this is what an image builder template looks like. So this is a lot of JSON, it's a lot of text, but there's 3 parts I want to call your attention to. This first part is the source. So as you can see, I'm using a rel 7 LVM image. This is from the gallery. That's the source that we're going to be using. The next part is the customization section. This is where we pass in the shell script that we want to use to customize, and I'll show you this script in a second. And this is the distribute section where we tell it, hey, once we've built the image, this is where we want to distribute it to. In this case, I'm using a shared image gallery, which is a really awesome Azure feature that lets you manage and distribute your images across various regions. So I told you I'd show you the customization script. This is all it is. We're just adding a message to the message of the day, and it says, hooray, you've been customized. We're not going to build this on the spot. That would take too long. Instead, I've built you a VM that I'll show you. And the point of me showing this to you is to show that this is really just a normal VM. Like, sure, it's being built from a custom image built by the image builder, but it's just a VM. It shows up as a standard Azure resource in the portal. So let's SSH into that. Here we go, message of the day, and that's our VM built using the Azure VM image builder. Now, my final question for you guys, and I want you to think about this. What do you do when you can't SSH into a VM? So when you're trying to SSH in, and you get that, and it's kind of just hanging there and sitting around. In Azure, this VM that I'm trying to SSH into, it's located somewhere in a data center, and I can't exactly run up to it with a keyboard and bang on the door and say, hey, let me connect this thing so I can troubleshoot my VM. We don't have that. But fortunately, we do have serial ports on every single VM in Azure. And what we do is we take that virtualized serial port, and it's bidirectional, so you can feed in input and you can read the output. We take that serial port, and we bring it over to you in the Azure portal, just like this. Here's the serial console. And that's what the Azure serial console feature is right here. So you can see there's nothing going on. It's still not responding, but once the serial console is loaded, you can see that there is output. And the VM is saying that it just failed somewhere, and it's dropped us into emergency mode, and we need to now go ahead and try to fix this thing. So now I have a shell. I can interact with it. This is great. So let's try to fix this thing. Usually, a lot of these errors come up in the FS tab. So let's have a look at it, and you can see at the very bottom, there is indeed an entry with a UID of 1 trying to mount on foo. So let's delete that, get out of there, and reboot.
How many of you did have to do this in the on-premises environment, just by show of hands? Few of you. All right, so this is kind of the cloud version of the same thing. So when you have your keyboard attached to the console of the machine, where you're able to do what Alfred just did, fix the VM by fixing the FS.tab file.
Yeah. And we have a couple features within Serial Console, too, that are actually really useful. One of them is the ability to send a non-maskable interrupt, an NMI. What this will do is forcibly crash your VM. So on a Linux machine, it'll crash it. On a Windows machine, you get a beautiful blue screen. And the reason why you would want to do this is you can configure your VM to take a memory dump when you crash it. So if you ever want to debug the contents of your memory, you use this, and then you look at it later. I'm not going to do that. Instead, we're going to try to SSH back in. Here we go, and now we're back in, and the VM's working. So with that, I'll pass it over to Jerome to talk a little bit about refactoring.
So usually the next step in the next option for customers is you move to the cloud. How do you take most advantage of the cloud? And usually the next step in the journey is to make your workload actually more cloudy. That requires a little bit of re-architecting, and that would take advantage of things like ARM template and Ansible playbooks. So the architecture is going to look quite similar to what rehost is, except there's a little bit more infrastructure around it to make sure that you have repeatable process as well as automation. Why would that be important? Well, if you're in the cloud, you want to make sure that if something goes down or if you want to be able to scale out, you want to have that automation so that in 1 or 2 clicks or edits of scripts, you can then have the application scale out. Or if the application does go down or need to be redeployed somewhere else, you have the automation to automatically redeploy it somewhere else. The tool that Red Hat provides for automation is Ansible. There's various other tools out there as well. And obviously, when you go to the cloud, once you've done the rehosting, moving to the automation gets you quite a bit further in the journey of the cloud. And the things to be concerned about is making sure that things are repeatable, redeployable, and automatable. Ansible gives you a really good framework to do this. Ansible Core is the piece that allows you to do the automation. And then we also have a product called Ansible Tower, which allows you to manage these automation, these playbooks at scale. And for you that might be migrating to the cloud today, if you are looking at that journey, it is feasible to think of doing the rehosting and this automation step at the same time if you plan accordingly. You don't always have the ability to do both at once, but if you can and look at the options available, you can actually do a little bit of the two at the same time. And with that, I'll pass it to Alfred for the next demo.
So let's do an Ansible demo. Jerome just talked about Ansible, and let's take a step back. You saw Cloud Shell earlier. This is our little Cloud Shell. Have you guys heard of Cloud Shell before? Any of you? Okay, that's cool, a fair amount of people. So for those of you that don't know Cloud Shell, you can think of it as a little VM in your portal that contains a bunch of tools. It's pre-authenticated into Azure, and it's a super fast way to get started with it programmatically, automatically, text-based, whatever you want to call it, interacting with Azure, as well as some other tools, such as Ansible. Cloud Shell comes pre-installed with Ansible. And if this is all up to date, it should show the latest and greatest Ansible version, which is 2.9, which actually came out on October 31st. So here we go. We've got Ansible 2.9. So I'll show you a little Ansible demo. Let me source my secrets. Can't let you guys see my secrets. That wouldn't be good. Let's have a look at this. This is a playbook. Just curious, we had an Ansible Terraform ARM pre-day yesterday. Was anybody attending in that? Yeah, okay, so this might be familiar. This might be a little bit familiar. But for the rest of you, this is an Ansible playbook. It's a bunch of YAML. It does some Azure stuff, as you can see. But more importantly, it also creates a resource group. It creates a VNet, and it creates a subnet. Now, why am I only doing these three things? Because it's fast. And this is supposed to be a fast demo. So let's run through this. And here we go. Now I'm running my Ansible playbook. I'll run it on the subscription. And one cool thing about Ansible, one important thing to know is that it's idempotent. So what that means is you have a playbook with a set of things that you want, with a state that you want to get into. Once you've reached that state, so in this case, once my VNet has been created, any repeated executions of the same playbook will have no effect. So you'll always be in that sort of desired state with Ansible. So it's going to gather some facts, and then it'll run through the playbook. And we should be able to see it in my Azure portal.
So one thing I want to ask you, Alfred, is could you show where you go to? So for those of you who have not seen Cloud Shell, where do you get into the Cloud Shell? You can probably minimize it and sort of show it on the UI.
Yeah.
If you log into the portal UI, so that little button on the left,
here.
that's where you get in the Cloud Shell. The first time it starts, it'll create a storage where it'll actually keep all the log files and all the artifacts that are present in the Cloud Shell. But otherwise, you literally can go to any machine, any browser. You can go on the go Wi-Fi on your internet online, and you can just work with that Cloud Shell without having to install anything. That's kind of the beauty of it. And it's for your Linux admins or people who have never seen Windows, it really doesn't matter what computer it runs on. You can just do it at the same time in the browser.
All right, so our playbook's finished. Let's get out of here. Let's get out of here. And what did my playbook even do? Let's have a closer look. So I created an Azure resource group called Ignite Ansible Group 1. So we should see a new Azure resource group called Ignite Ansible Group 1 in my list of resource groups if I refresh it. Here we go, Ansible Group 1. And within there is indeed a VNet. And within the VNet, let's go over to subnets. Here's our subnet. So that was Ansible in a nutshell. Obviously, I'm not going to go into much more detail here, but there are sessions later this week that will. So check out your Ignite app and go check those out if you're interested in those. Back to you.
Thank you. So I guess the point I want to highlight that Alfred just demoed, maybe sometimes those things go too fast. It's the familiar tooling that you probably have been using or your Linux admins have been using on premises, and it's the tooling just available and works on Azure. So our goal is for it to be transparent and for it to be natural. The way you do it on premises, it should work on Azure. If it's not the case, definitely please complain to us. We'll listen to feedback. We want to make it so. So with that, I'm going to cover briefly the third part of the journey. It's the re-architect journey. Again, you don't have to re-architect from the beginning. One of the beauties you can do, you can just lift and shift and drop stuff into the VMs and work with the VMs to begin with. Now, if you have decided to sort of separate the components of your application, split it into containers, put the boundaries, use different programming languages to implement those different boundaries. You can use managed services like Red Hat OpenShift or higher level abstracts like Azure Kubernetes Services or any of the services we've been showing in the prior slides. That's where that variety will come in handy. Again, you don't have to do it at the beginning, but once you reach that stage, you should look into the past services and various services we have available in Azure that work with Linux or work for Linux. Now, since we're focusing on Red Hat today quite a bit, so one of the things we have in Azure is ability to run Red Hat OpenShift. And you have a couple of options in this case. So you have a fully managed solution. That's when we run those clusters for you, and we just give you the connection points, just like the Azure SQL DB. You don't really care where it runs, how it runs. We take care of the availability and high availability and security of it. You just get to use it. Same thing with a fully managed Azure Red Hat OpenShift. You can get it. You can provision it from the portal. Or you can have a self-managed service or self-managed option where you deploy the OpenShift, Red Hat OpenShift on your own over the virtual machines that you provision in the Azure itself. Again, this could be versions, Red Hat OpenShift Container Platform version 3 or 4 that are both available on Azure. It's an easy way to get started, easy way to explore before you really need full commercial support that you will get through the fully managed version. And with that, let us finish with the one final demo. That's the demo of Red Hat OpenShift on Azure. Alfred?
All right. So Boris mentioned we have two different offers. There's the fully managed offer, and then there's a self-managed offer. This is what the self-managed offer looks like in the Azure portal. Once you finish installing it, you get a bunch of Azure resources inside a resource group, but really this is just the guts of something, and you probably don't care about this if you're an OpenShift user. So this is what the OpenShift looks like, and you can see this is a very, very new cluster. I've got one app running on it. It's so new that I haven't even made myself a proper admin user yet, but that's okay. And this app is running at this endpoint, and we've got a little Node.js application. Hello, Ignite. So what are we going to do? Well, you can do so many things with OpenShift. What I will show you today is a push-to-deploy workflow. So we have this web app here, and we've also got the code for the web app right here. So this is the index.html. This is what you saw back on the other page. And we'll just make a quick change to the text here. So instead of welcome to your Node.js, we'll say, hope everyone is having a good time. And now, we'll check that this is the only thing that I've changed. We'll add everything.
So just, I want to comment on what Alfred is doing. So this might be going too fast. So what he's doing, he is editing the source code of his website, and he's doing it on GitHub, right? So he's doing it through the Visual Studio Code. He's just making a change in the Visual Studio Code on his local machine, and he's pushing it to GitHub. That's literally what he has done. He just changed one line and pushed it out. And that's kind of, let's see what happens behind the scenes.
All right, so this thing's pushed up. And I'll show you the repo, because there's one thing I want to call out that's super crucial to this whole demo here. And within the repo, I mean, if I refresh the page, I'll be able to see that I have a new commit from 33 seconds ago. I'll also want to check that my webhooks are working, pointing to my OpenShift cluster from GitHub. So this is what enables the whole push-to-deploy workflow that I mentioned earlier. Basically, I have my source code in VS Code down here. I push that up to GitHub. GitHub sees that there's something new that just appeared. There's new code, new commit. And it fires an event over to OpenShift and says, hey, something just got pushed. Do something. And what OpenShift is going to do is it will pick up on the event, and it will actually rebuild my application. So if we head over to the build section, we can check out the list of builds. And we can go to the latest one. You can see there is a build running right here, build 14 at the bottom of the screen. And we can see it's running. But the cool part is we can also see the logs. So what I showed you, you remember this from a minute ago, this Azure portal, all the guts of everything that's happening inside your OpenShift cluster. Somewhere in this list, something is running, and something is also streaming the logs directly to your OpenShift web console here so that you can see what's going on. So this thing is currently building. It's the new deployment. And soon we will be able to see a couple different things. We'll be able to see this will scale down from 1 pod to 0 pods as it nukes the existing pod and builds the new one and puts the new build on it. We'll also see this web page go down. So once this thing hits 0, we can refresh, and this thing will say, hey, application not found. Give it a couple more seconds for the build to complete. Let's double check the build, see how it's going. check out the logs. Almost there, and I think it's done. So let's have a look. Let's go back to the topology. Let's have a look at the main. And we'll see this thing soon scale down from 1 to 0. Here we go. We're at 0, which means, boom, the old application is now no longer available to us on this route. And what it's doing is it'll rebuild the pod. It'll push the new deployment out to the pod. And then this route will come back up, and we'll be able to see our new application with the changes.
And again, I'm going to add to what Alfred is showing right now. So he deployed on a single pod, which means it's not highly available configuration. So that expected, it is absolutely expected that the site will go down. If he deployed 2 of them, the OpenShift would have taken care of taking 1 node down, bringing the new build on it up, and then doing the same thing with the second node. So you would not have seen that outage. You would just have seen the same page over and over again until both of them are actually up, and then this name, the title string, as you can see right now, would have been changed. Again, the point of this demo is there's a lot of guts of the OpenShift. There's a lot of complexity in this. You don't really care about this. It just runs on Azure. That's one important aspect you want to see out of it is the OpenShift runs on Azure, and you can work with the OpenShift regardless of where that platform runs. So that's the beauty of it. So you can just use it this way. Anything else?
So just to recap, we had our code. We pushed it to GitHub. GitHub sent an event over to OpenShift. And OpenShift managed to rebuild it and push out a new updated build to a public endpoint. So if you guys, if you really want, you could pull out your phones and type this URL and go visit this page right now. And it's all running on OpenShift on Azure.
Thank you.
Back to you, Boris.
All right, so this pretty much completes the set of things we wanted to talk about today. And if you had to remember just a few things out of this session, so definitely remember the fact that hey, we can run Linux workload on Azure. If you're seeing any kind of problems, definitely talk to us. We are spending an enormous amount of time on making sure fundamentals and the end-to-end experiences of Linux are easy to be running on Azure. And finally, if you have any questions, definitely find us at the hub. We're here the whole week. So any one of us, and there are a few people in the room who work or focus on working on Linux and Azure. And thank you for coming. Now, before you go have another beer, please fill your evaluations, and then you get a second beer. Thank you.